printf %.2f \n fl return 0. We can see at the line 4 in the program that we are seeing, the computer reserves memory for fl. In our examples, we will assume that a float requires 4 bytes. Depending on the computer's architecture, a float may require 4 or 8 bytes of storage. We can see the picture on the screen. When FL is used in line 5, two distinct steps occur. First, the program finds and grabs the address reserved for FL. In this example, 924 or 924. In our example, FL is not a single byte. It is made up of 4 bytes with 4 addresses. In step 1, when the program grabs the address, it grabs only the address of FL's first byte, that is 924. Coming to second, the contents stored at the address are retrieved. The program knows FL is a float and that all floats have 4 bytes. Therefore, when the program does step 2, it knows to retrieve the contents in the 4 bytes starting at the address 924. To generalize, whenever any variable is accessed, the above two distinct steps occur to retrieve the contents of the variable. The standard string library string.h contains many useful functions to manipulate strings. Some of the most useful functions are strlen of S1. This returns the length of S1. strcpy S1, S2. This copies S2 into S1. strncpy of S1, ct, n. This copies nth character of ct into S1, where ct can be any text or string. strcat of S1, S2. This concatenates S2 to the end of S1. strncat of S, ct, n. This concatenates nth character of ct to end of S. strcmp of S1, S2. This compares S1 and S2 and returns one of the following. That is, it returns a number less than 0 if the first character in S1 is less than its corresponding counterpart in S2 in terms of its ASCII value. Or it returns 0 if both S1 and S2 are same. That is, each element in S1 is equal to its corresponding counterpart in S2 in terms of its ASCII value. Or it returns a number greater than 0 if the first element in S1 is greater than its corresponding counterpart in S2 in terms of its ASCII value. Now let us consider the following code which uses some of these functions. String.h, this is the header file I am including. Coming to main function, char line of 100. This declares a char array known as line. strcpy in parenthesis line comma in double quotes hello I am a string. Printf line colon %s \n line. strcat or strcat line comma in double quotes xyz question mark. This is to add xyz to the end of the string line. Printf in double quotes line colon %s \n line. Printf length of line colon %d \n, this is in double quotes, strlen of line. This prints length of the string and also it finds occurrences of substrings. Let us see a program that displays each element of the array on a new line. stdio.h, this is the header file I am including. Coming to main function, declaring the variable I, int I, char array of 11, printf enter a string of maximum 10 characters \n, get s of array, this reads the array, fflush stdin, this clears the buffer. Let's take the for loop now. I equals 0, array of I not equal \0, I equals I plus 1. We know we need to separate it by semicolon in a for loop. Start of for loop. This for loop what we have written, this is the start of the for loop. Printf element %d is %c \n, I plus 1 array of I. This prints the values of index array. When I execute this program, I get enter a string of maximum 10 characters. Welcome ABC, element 1 is W, element 2 is E, element 3 is 1, element 4 is C, element 5 is O, element 6 is M, element 7 is E, element 8 is A, element 9 is B, element 10 is C.